All right, ladies and gentlemen, so here in this problem, we're looking at another exponential equation, and this time we're going to be working with this transcendental number e, okay, and we're also going to be working with substitution, okay. So this is a quadratic equation, and we have to first do some substitution, all right. What that means is we have to let, I'm doing it off here, let's let u equal e to the x. All right, so that's important. Everywhere I see an e to the x, I'm going to put a u. Now this first term is a little bit tricky. So we have here e to the power of 2x. Now you could write that e to the power of 2 raised to the power x, right? Or you could write that e to the power x squared. If you apply the power rule to the exponents here, you see there's no difference because it's either e to the 2x or e to the x times 2, which is the same thing. So we want to use this one because it creates this squared term. So we're going to let u equal e to the x. So when I rewrite this equation, I'll write 10u squared. That's probably the most confusing part of what we're doing here. Minus 31, and here I just got e to the x, so 31u plus 15 equals 0. Now, the next step is really up to you. I have a colleague who says, by all means, just plug this quadratic equation into the quadratic formula because it's a little bit faster, okay? I am more partial to using completing the square because I like it. Okay, so if you're watching the video and you wanted to see the quadratic formula, if you know it by heart, then you're totally free to use it. All right, I like completing the square, and I'm making this video, so I'm gonna do completing the square. So, with the first step to complete the square is to subtract this constant term from both sides. Okay. And then we'll rewrite what's left. I've got 10u squared minus 31u. I'm going to leave a space there because I'll need that space here in a second. And then I've got that set equal to negative 15. We look at the first term and we see that it's got a coefficient greater than 1, or different than 1, I should say. And so the next step is to just divide every term by 10, because we need to get the u squared with no leading coefficient. So just every term is blanket divided by 10. Okay, 10u squared divided by 10 is just u squared, which is what I wanted. And then we'll just write minus 31 over 10u equals negative 15 over 10, which can be simplified by dividing both the numerator and denominator by 5 to negative 3 over 2. Okay, so this is negative 3 over 2. Okay, now when we complete the square, we have to take half the middle coefficient, which is negative 31 over 10, okay, times 1/2. We have to take half that middle coefficient, and then we have to square it. Okay, so over here in side work, I'll show you what I'm talking about. I've got to take negative 31 over 10, okay, multiply it by 1/2, and that's going to equal negative 31 over 20. And we have to square that. Okay, so that's equal to negative 31 squared over 20 squared, which is 400. Okay, so what's negative 31 squared? Well, I've done the work. 31 times 31 is 961. So this is going to be 961 over 400. Okay, so that's the square of half that middle coefficient. And so we always write that in this blank space, plus 961 over 400. And then because we added it to the left side, we have to add it to the right side, plus 961 over 400. Okay, now on the left side, we're going to, this is how it always works in completing the square. You're going to be able to take this little quadratic here, cover this up and forget about it. You're going to be able to factor this quadratic like this. It's always going to take this form. U minus half the middle coefficient, which is negative 31. So 31 over 20, so U minus 31 over 20 squared. So we have a perfect square binomial equal to, and now we have to add this together. Well, we have to get a common denominator between 2 and 400. So I'm going to have to multiply both the top and the bottom here by 200. Okay, so negative 3 times 200 is negative 600. And 2 times 200 is 400. So now I have a common denominator. Okay, and so we'll just combine these together. Negative 600 plus 961 is 361. So this again is U minus 31 over 20 squared set equal to 361 over 400. Now both of these terms, if you're completing the square, these will always be perfect squares. So the square root of 361 is 19. If you didn't know that, you could just put it in a calculator. And the square root of 400 is 20. So what we're going to do to get rid of this squared term and start to get u by itself is take the square root of both sides. Okay, so now I've got u minus 31 over 20 equal to plus or minus, and now I'm going to break this square root up, the square root of 361 over the square root of 400. Okay, so one more time I'll rewrite that left side, u minus 31 over 20 equals plus or minus, and now I can simplify these square roots into 19 over 20. And now I add 31 over 20 to both sides. Okay. Over here we cancel each other out. Now I've got u all by itself equal to 31 over 20. Well, let me write it this way. I have a common denominator already, so I can write 31 plus or minus 19 all over 20. So as you see, I'll have two solutions, as you would expect with a quadratic equation. So we'll call one of them u1, and we'll call the other one u2. So let's figure these out. The first one's going to be 31 plus 19 over 20. And the second one's going to be 31 minus 19 over 20. All right, so a little bit of math involved there. 31 plus 19 is 50 over 20. Which reduces down to 5 over 2, which we'll write as a decimal at 2.5. Okay, so that's one solution. The second solution is 31 minus 19 over 20, which is 3/5. 12 over 20, which reduces down to 3/5. Okay, divide both top and bottom by 4, you get 3/5. And 3/5 is equal to 0.6. All right, so that's u. Okay, remember we said that u is equal to e raised to the power of x. So now what we're going to write, let's go over here and let's evaluate these. I've got my solution 1 is, well, not my solution 1, e raised to the power of x is equal to 2.5, okay, and e to the power of x is equal to 0.6, okay. So here I'm going to take the natural log of e to the power x and the natural log of 2.5. Same thing here, ln e to the x and ln 0.6. All right, so that allows me to bring down this x. X is equal to ln of 2.5. And over here, x is equal to ln of 6. All right, so you have to approximate these. You have to use a calculator. There's no way to do it by hand. So we'll take ln, I'm going to press this ln key here, ln of 2.5 and get 0.916. And take ln of 6 and get 1.79. Okay. These are, I should have said, approximate solutions, right? Because they go on forever, as you see. Irrational numbers go on forever. So these are your two approximate solutions. And the ones above them are your two, what we call exact solutions. Right, so there you go. And that is how we incorporate quadratic equations into solving exponential equations. All right, so that was all the work required for that. It's a good meaty problem. I think using the completing the square method really is a little bit more cognitively demanding than just plugging it into the quadratic equation. Nothing against the quadratic equation at all. It's more efficient, but I think this one, completing the square, is more analytical. Okay, so again, I hope this was helpful. The only way to learn these types of problems is by doing them, and here we are doing them, so we'll keep doing them in a future video. Thanks for your attention.